Welcome back to 3D Decode. Today, we're diving into one of the most practical API standards, API 614, Lube Oil Systems. Why is it important? Because every API compressor or pump needs a reliable lube oil system to keep bearings, seals, and couplings alive. Let's break it down. Purpose of a lube oil system. The lube oil system, often called LOS, has one job: keep the machine alive. Provides continuous, clean, cool oil to bearings and couplings, removes heat generated by friction, protects against wear, contamination, and failure. Maintains proper pressure and flow, even during startup, shutdown, or emergencies. In short, no oil system, no machine survival. Two major components in a typical LOS, API 614. Oil reservoir, tank. Stores system oil, sized for at least 5 minutes of circulation at normal flow. Sloped bottom for sludge collection. Main oil pumps. Redundant design, 2 times 100% or 3 times 50% capacity. Types, gear or screw pumps. 1 motor-driven plus 1 turbine-driven or electric standby. Coolers, shell and tube, water-cooled or air coolers. Maintain oil at 40 to 50 degrees Celsius. Filters, duplex filters with changeover valves. Continuous operation. Filter rating, approximately 25 micrometers absolute relief valves. Protect the system from overpressure. Instrumentation, pressure gauges, temperature indicators, flow meters, differential pressure indicators. Overhead tank, emergency oil supply. Located above machine, gravity fed. Provides 5 to 10 minutes of oil supply if all pumps fail. 3 API 614 requirements. This standard is strict because reliability is critical. Redundancy, at least 2 pumps, 1 running plus 1 standby. Reservoir, must have low-level alarm plus trip. Filters, must be duplex, switchable online. Coolers, must handle 100% load with 1 cooler in service. Emergency system, overhead tank or accumulator required for critical machines. 4 typical LOSP and ID flow, simplified. Oil reservoir, main pump, filters, coolers, machine bearings, the seals, return to tank. Standby pump connected in parallel. Overhead tank feeding bearings in case of failure. Mini quiz, drop your answers in the comments. 1. Why is an overhead tank used in a lube oil system? 2. What type of filter arrangement is required by API 614? 3. What is the typical operating oil temperature range? 4. How many minutes of oil supply should the reservoir provide at minimum? Practical task. Sketch a basic lube oil system. P&ID with reservoir, 2 main pumps, 1 running plus 1 standby. Duplex filter, cooler, overhead tank, bearings, consumer. This practice will help you in interviews. They often ask candidates to sketch a simplified lube oil system on the whiteboard. Interview Q&A, Day 4. Q. Why is redundancy required in lube oil pumps? A. To ensure continuous lubrication. If 1 pump fails, the standby takes over automatically. Q. How are duplex filters beneficial? A. 1 filter can be serviced while the other stays online, preventing shutdown. Q. What happens if lube oil temperature rises excessively? A. Reduced viscosity, poor oil film, bearing failure. Q. Why is an emergency oil system mandatory? A. To protect bearings during pump trip or blackout, avoiding catastrophic damage. Q. Which standard governs lube oil systems for compressors and pumps? A. API 614. Outro. That's all for today's deep dive into API 614, Lube Oil Systems. If you found this useful, don't forget to like, subscribe, and share your answers in the comments. This is 3D Decode, where we simplify complex engineering topics. See you in the next video.